Okay, so what we're going to do right now is we're going to work on some of the properties of logarithms. And one, hopefully this video will show you why some of the properties that we're doing work. Also, they're just proofs, just as you had in previous courses, specifically geometry. Um, let's go ahead and just dive into it. Okay, so if I would like to do the product property. Okay, if I want to do the product property, okay, the product property is going to tell me that if I take, let's say, logarithm with base x of a times b, that's going to be equal to logarithm base x of a plus logarithm base x of b. Okay, so this property basically just says if you're multiplying two parts on the inside of your logarithm, you can, as long as the base is the same, you can go ahead and split it up and say base x of a plus base x of b. Okay, and I am going to prove that to you right now. So let's start with if I have x to the L power, and I say that that's equal to A. Okay, we can rewrite this using logarithms. Okay, so my base is x, so that means I can say my logarithm base x of A is equal to L. And this makes sense, right? Because this is how we find exponents when we're given certain bases and what it's equal to. Okay, I'm going to do that same thing, but just with some different numbers. So I'm going to use the same base. But instead of L, I'm going to say M, and we're going to set that equal to B. All right, and so then I can rewrite this logarithm as saying log base x of B is equal to M. All right. Well, I'm going to even set up a third one here. I'm going to say that x to the n power is going to be equal to a times b. All right, and so if I have logarithm base x of a times b, I know that that's going to be equal to n. Okay, so let's just take this expression here and let's write it down here. So I'm going to take x to the n power, and it's equal to a times b. Okay, so this top part was just a little bit of setup. Realistically, the letters don't really matter as long as they're consistent with previous properties that we've dealt with. Okay, so I have x to the n power is equal to a times b. Well, luckily, I actually know what a is equal to. So let's actually do a little bit of rewriting and say that x to the n power is equal to a. So what is a? A, to me, looks like it is also the same as x to the L power. Okay, and that b is equal to x to the m power. Okay, so all I'm doing is just, this is the substitution property that I'm replacing a with x to the L power and b with x to the m power. Okay, so now we need to know a little bit about our exponent properties, specifically that when I am multiplying the same base together with exponents, that is the same as reducing the base together and just adding L and M together. Okay, so let's look at this. I have one base x and they're equal to each other and they're being raised to a power. So n x to the n power is equal to x to the L plus m power. Well, if I'm looking at this, if I'm raising the same number to a power, I know that these exponents are going to have to be the same. So now I actually know that n is equal to L plus whatever m is. Okay, so we know that n is also equal to L. What is L equal to? Well, if I look at this, L is actually equal to log base x of a. Okay, so log base x of a. And m is equal to log base x of b. So, I know that n is equal to that, but n is also equal to log base x of a plus b. So I'm going to go ahead and just, instead of n, I'm going to say log base x of a plus b. All right. And actually, that's the proof. Okay, so let's just look at what we did, just with a little bit of symbol manipulation here. Log base x of a times b is equal to log base x of a plus log base x of b. Okay, and and really what this is saying, that if I have two parts here in the base, I can split it up using addition. And that is our product property proof.